We have our basic working skeleton, and we'll now want to add weights to our character so that the skeleton can actually deform the mesh. For the moment, I'm going to isolate the bones which I'm going to use for the deformation. This is not necessarily the best approach, but it is useful to know how to do this. So I'll create the setup even if I remove it later. So first I'm going to isolate my skeleton. Currently I have the skeleton that I've isolated for the rig, and this still includes the root bone. I'm then removing this root bone. I want to be able to reference this rig at this point in the network, so I'll place a null here and I'll reference that. This is easier than trying to reference the delete node directly. I will give this null a bone shape for easier visual feedback, and I'll name this node rig skeleton. I'll now reference this for my deformation, and I'll do this using an object merge node. So we'll reference our rig skeleton, and I'll import it into this object. We can then start in the capture, and we'll start this with the bone capture lines node. This node will create the bone capture attributes, which will be used to generate the weights for the skeleton. I'm then going to get an attribute wrangle node so we can specify which joints are going into the bone capture lines node. This will be done using the name attribute. The points that we are going to be removing are the effectors for the head, the abdomen, and the legs. We'll want a conditional so we can isolate these joints. If at name, we'll then look for the last 3 digits. This is why I gave the effector suffix to the final joints in the chain. So we'll have square brackets, -3 because we're starting with the third character from the end, and then we'll use a colon to specify this as a range, and we'll check if this is equal to EFF. If it is, we'll then set the name attribute. This will be at name, and this will be set with the name attribute, so once again at name, and we'll want all of the names starting at 0, then a colon to indicate that this is a range, and we'll go to the third point from the end with -3. So now we've renamed all the final joints to match their preceding joints, which means that the weight should treat these points to be the same. As I stated earlier, this is not automatically best practice, and I may change my mind as to whether I want to do this or not. I also have some other issues here. For example, my final joints for my abdomen is abdomen, and the final joint for my head is head. However, I've named the initial joints abdomen root and head root, so these joint names do not actually match up with the renamed effectors. There are numerous ways in which I could deal with this. Probably the best long-term solution would be to rename the joints in the actual skeleton, but for now I'll use a more simple workaround. So I'll create a conditional. If the name attribute is equal to, in this case I'll look for the head, and then we'll perform our operation. We will then need to set the abdomen. So if the name attribute is equal to abdomen, I'll need to perform this after I've set the name initially, so I'll move these operations. So if we have the head, we'll set the name attribute to head root, and if we have the abdomen, we'll set the name attribute to be abdomen root. This is messy, but it will mean that I have consistent names for both my head and my abdomen. So we've now updated the geometry names. I will not be changing the bone capture lines node at all. The next thing that we'll need to do is spread the capture data over a 3D space. To do this, we're going to create a mesh, and this mesh will fill the volume of our original mesh, and to do this we're going to use the tet embed node. The first input will be set by our mesh, and the second input will be set by our bone capture lines node. The tet embed node should have no enlarged offset. I can do this by either setting the input to 0 or turning off enlarge input mesh. We now have our information for our weights, and we're applying them to a volume. We can now create the weights themselves. We'll do this using a bone capture biharmonic node. The first input will take my original mesh, and the second input will take my tetrahedral mesh. I now have the weights for my mesh. I do not, however, want to have these weights constantly being updated, so I'll get a stash node, and I'll stash the input. This way I'll only evaluate this network from the stash node. At this point we can update the weights. To do this, we'd use a capture layer paint node, and this node will be connected to our stash node. So I'll now just move the network down so we can see more clearly what we need to attach. There are currently two more inputs which we have not yet set for the capture layer paint node. The first of these will be for our default rig pose, and the second one will be for our deformed rig. This will of course be the rig which comes at the end of our animation. I'm going to reference this with an object merge node. So the object reference here will be for my animation rig out. And this node should be setting my third input, and that will be used to reference the weights. We can then see the actual deformation with the bone deform node. The inputs for this node are actually the same as the capture layer paint node. The first input will be set with our mesh, and the third input will be set with our animation. As stated earlier, the second input will be set with our rig itself. To do this, I'll get an object merge node, and I'll reference the rig skeleton node. So essentially we are setting the mesh with the first input, the second input will give us our skeleton, and the third input will give us the pose for that skeleton. This pattern will follow through with most of the nodes in KineFX, and will also be used for our export nodes. So I now can animate my skeleton, and we have deformation for the mesh itself. And while the setup is still very rough, we have an animatable character now. The next thing I want to do is be able to export this mesh. In this case, I want to be able to export it to a game engine like Unreal or Unity. So I'll do some final work in order to prepare for that. First, I want my deformation to be my final output. This will be the visual output for the mesh at the moment. I will then get another null. I'll connect this null to the deformation, and then I'll duplicate it. This null is going to be used to reference my weighted mesh. So this null should actually occur before the deformation and should be connected to my final weights. In this case, it will be connected to my capture layer paint node. This null will be renamed to weights out. I'll call the null connected to the bone deform node my deformation out. So now we have terminal nulls for our deformed rig, our weighted mesh, and our final animation. In order to make these slightly easier to see, I'll color the animation bone green, and I'll give my object merge for the animation the same color. I'll make the object merge for my rig a blue, and I'll color the rig null, which I'm referencing, blue as well. I'll then rename these nodes. We'll have the animation merge, and we'll have the skeleton merge. So I've finished the basic deformation. In the next video, we'll start working on the export pipeline.